Hello, everybody. This is Brian Smith here with 321 Gang. Welcome again to our technical podcast, Change the Conversation. And we are pleased to have with us again the indestructible sword, Amit Talvar. How you doing, Amit?
Good. Thanks, Brian. Thanks for having me back.
Yeah, you bet. We want to try and keep these pretty tight, so let's jump right into it. In our last podcast, we were talking about some of the basics of A-Spice, why it's important, who uses it, automotive industry. There's problems and challenges around integration, suppliers and OEMs. About as a broad brush as I could possibly give A-Spice, considering that it's quite a technical process. And what we towards the end of it, I recall that we were discussing requirements quite a bit, requirements management. It seems to me that requirements management is sort of the hub of the A-Spice wheel in which everything else sort of revolves. Is that a correct assessment? Again, broad brush.
Yeah, it is. It's just the starting point. You look at any engineering organization and requirements management, it is probably the most important process that they have to go through, because if you get the requirements wrong, you're just looking at additional costs and trying to fix things down the line. So it's really important. You take a heavy investment in making sure requirements are managed correctly, that you've got the requirements right, that you're implementing those.
Mm-hmm. And that you're testing against them and finding
Exactly.
problems early and things like that. Yeah, because as we mentioned in the last episode, it's been known for quite a long time that it costs at least 10 times more, or maybe I've seen 100 times more to fix something at the end of an engineering process, whether it's software or hardware or some combination of systems engineering, than it does if you catch it early on. So
Exactly.
super important.
Yeah.
Super important.
Yes.
Well, here we are in episode 2, and we're calling this one, let me cheat here, Establishing Traceability and Ensuring Consistency. That seems to be a fairly important tenet of A-Spice. Is that correct?
It is. It is a common-based practice across the different systems and software engineering process groups, and it is probably one of the ones where we see organizations struggling with it.
Mm-hmm. Okay. Well, we laid the groundwork in the last episode for why people jump into A-Spice. So let's talk real briefly about how organizations who want or need to look into using A-Spice get started. How do we do that?
So the driver really is, organizations, A-Spice, as we, going back to the first episode, it was really a standard developed by the OEMs as a way of being able to assess their suppliers. So what we see in the industry is the suppliers, they want to identify where their gaps are before they actually go through and actually get audited by the OEMs. And what we're seeing,
right. I see what you mean. Mm-hmm.
Yeah, what we're seeing is they'll either have internal assessments done on by their own assessors that they have in house, or they'll hire some third party to come in, and they'll identify these gaps and they try to address those gaps.
So there's an assessment. So there's a formal assessment process that goes on. There are experts out in the field who are A-Spice assessors.
Exactly.
I see.
Similar to a CMI assessor. They'll come in, they'll do an assessment, identify those gaps, give you a rating. And same thing, they do this before they actually get audited by the OEMs. If you look at a lot of contracts, before they're even able to bid or bid on a contract, or even if they win a contract, they have to reach a level of A-Spice rating by start of production.
Interesting.
So
interesting. Okay.
So they really are pushing it to understand where their gaps are and making sure they have a strategy to fill them.
And is the reason for the OEMs wanting their suppliers to have this does that come down to some complexities around integration through the supply chain, things like that?
It is exactly what it is around, right?
Okay.
The OEMs want to ensure that the products that they're getting from the suppliers is what is, because at the end of the day, the OEMs are liable right, for what they
Sure.
integrate into the vehicles.
Uh-huh.
So
Yeah,
they want
yeah,
to make
absolutely.
sure that their own processes are being followed. They want to make sure the suppliers are following them also.
Absolutely. Hey, and I want to tell you that I appreciate the correct word use of the word ensure versus insure. I can't tell you how many times I see the word insure on marketing things all over the place when people
Yeah.
are really saying, meaning ensure. So good stuff. All right, that's my little pet peeve for the day. So we talked. So okay. So let's dive down a little bit more. And what do organizations who want to adopt A-Spice typically struggle with?
So what we see in the marketplace when we come into organizations, right, establishing traceability, it's the title of our talk today, establishing
Yeah.
traceability and ensuring consistency is where we see the most amount of struggle. And that's the gaps that are commonly identified. Um, organizations can establish traceability in multiple different ways. They look at, using naming conventions or tags, right, to be able to manage traceability across their different engineering artifacts.
Mm-hmm.
But the gap there is, they can't ensure the consistency because if something changes, it's a manual effort to update
Right.
without being able to get notified. And so there has to be a way for it to be kind of automated and for people on
Mm-hmm.
both sides of the change to understand if there is a change, something's actually affected. I have to go do an impact analysis to understand is there something on the other side that needs to change, right, to make sure that that traceability is consistent. And that's where we see struggles. And our continuous engineering platform really is a differentiator for us. It assesses that area and actually implements consistency on it very well. And we're actually going to show that today.
Okay. That's IBM's continuous engineering platform. Yeah. So,
That's correct.
so we're going to give people a little view of that. So good. You talked about we keep coming up using the word traceability, and I think the artifacts and elements that we're talking about then are requirements, the tests that validate those requirements, any models that are part of that overall process that are linked to those requirements and tests, and I suppose that in automotive there must be regulatory and compliance types of things that need to be part of that. Would those be the four or the main groups of things that we're talking about
Yeah, I mean,
regarding traceability?
if you look at the engineering software, the systems engineering process groups, there's I think 13 or 14 base practices on
Uh,
establishing bidirectional traceability and ensuring consistency.
I only
Um,
missed 10 then, so that's good.
yeah, so it's from stakeholder requirements down to your
Right.
system requirements, down to the system architecture, down to software requirements, the software architecture, to the detailed design. And then at every level across on the right side of the V, you're looking at making sure that every side of that has, a test specification or a test case associated with it. So you're actually validating that you've actually implemented what you designed. And you're
And so,
validating that it passed.
yeah. So essentially, that's the why of this. Why is it so important, right? We talked earlier about making sure you find issues early on in the process. Obviously, automobiles carry people, and so you can consider this a life or death situation in some cases when you've got hundreds of electronic systems all communicating with each other and even seeing externally with cameras and automated braking systems and um, uh, yeah, airbags, that's the word I'm looking for.
Yeah, yeah,
and driverless cars and all those things. So I think the why
exactly.
is in this context pretty apparent. So why don't we then, I think you said you have a slide that you want to show us first
Yeah.
before we jump into a real quick demo of IBM's continuous engineering platform.
Yeah, as we showed in our last episode, here's the automotive spice process reference model. We're going to focus today on the systems engineering, software engineering process groups, but I just want to set some context there. The IBM's continuous engineering platform covers multiple areas in this process reference model. Requirements management solution, which is Doors Next Generation, covers the requirements analysis and elicitation areas. We have our Rhapsody solution, which covers architectural design. We have our Quality Manager solution, which covers the software and system integration test and verification areas. And then we also have Rational Team Content that can cover some of the project management, risk management, measurement areas, and also along with the configuration management, change request management, problem resolution management. Now there's
That's
multiple
also code control, right? Code.
Exactly.
Yeah.
Yep. The source code.
Source code.
Yeah. Now, the benefit of our integrated continuous engineering platform is the ability that we have all these areas that handle, these process groups. But if you look at the base practices where we talked about where organizations struggle, it's establishing the bidirectional traceability. But the main one is ensuring consistency. What we see in the marketplace is, you can do bidirectional traceability, we mentioned many different ways, but ensuring that traceability is consistent is where we see that being a big gap. And from an assessment standpoint, if you fail that base practice of ensuring consistency, you fail the whole traceability, you fail that whole base practice. And we'll start seeing those organizations get a level 0 in that area.
Right. That's similar to the CMMI stuff we talked about in the last episode where, consistency, adopting a practice and then being consistent in that practice is a key element to it.
Yeah. And so one of the things with consistency is if there is a change to a requirement, making sure that the test case, there's an impact analysis to understand that does the test case need to be updated? Does a lower level requirement need to be updated? What's the effect of making that change? And so we'll show you in the demonstration how you can actually, see those changes. So if something does change, what the notification is and how you can set up things.
Great. So yeah, let's jump into it. All right. What are we looking at here?
So here we're looking at our continuous engineering platform. We got a view showed up where we're seeing a list of our system requirements. Right? Each one of those requirements have a unique identifier, lets us be able to identify them. But the important thing here is what we talked about is establishing that bidirectional traceability and ensuring consistency. So we can look at this requirement itself is actually being described and actually satisfied by a state chart, a part of our architectural, our system architecture, right? So we can take a look at that. And we can navigate through that so we can see that with the way that we've described how we're going to actually implement that requirement is through the state transitions of how our system's actually going to move from one feature to the next.
So is that a pretty high level requirement then?
It's a high level functional system requirement. Yeah.
Got it.
Now that can be that's just an example. Right. You could also get down to individual blocks in your requirement if you wanted to say, hey, this unique block inside the vehicle display is actually going to satisfy the implementation of this requirement.
Now, just to be clear here, the a block and a state chart, those are elements of model-based systems engineering, right?
Exactly.
Okay, good.
Yeah. So as you decompose your system requirements, part of ASPICE is to make sure that we allocate those requirements into the system architecture.
Got it.
This is the way that we establish the allocation of the requirements into the system architecture.
Okay.
But we also look at ASPICE's making sure those requirements at each level, whether it be at the software architecture, the software requirements, or system architecture or system requirements, that we have established test cases that are going to actually go through and validate those. And so what we're seeing here is we have a list of test cases that are actually validating those, that are associated to those requirements as here's what's actually going to validate it. And what we see as part of our platform is we have this ability to have rich hover. So even though these test cases live in some other solution area in another application, we have visibility into it. So from a systems engineer perspective, I can actually see, the progress of these test cases. There's some quick indication right here. We can see that the last time this actually ran, there's a green check mark. that we actually had a past result. So we know that this requirement has been validated and verified.
Mm-hmm. Cool. Now, what about the question mark next to it? Does that mean that there's something that needs to get validated a second time, or?
So that's the part about ensuring consistency. So part of our platform is the ability to understand the bidirectional traceability between these two elements, these two artifacts. We have the requirement and the test case, and making sure that they've been established and that those links are valid and consistent. So right now it's marked as a question mark. So somebody has to go through once it's been established and mark this as a valid. So we go through and mark that as valid. Now we know that this link is consistent. But say somebody goes through and makes a change, right? I'm going to go ahead and make a change to this requirement. As soon as I do that,
that ought to go back to a question mark, right?
It goes right back to a question mark, right? And so we have the ability to set up notifications that way, so the test engineer that's working on that test case can get that notification. He'll see that marked as suspect, and he'll know that I have to do some impact analysis to make sure that my test case is still valid.
Oh, that's cool.
That I'm actually testing the right thing in the requirement. It can be, yep.
Yeah, cool.
Yep, multiple different ways to set up notifications. Dashboards, email notifications, yeah, many different ways.
Drones. No, I'm only kidding.
Yeah. But this is also even going down. If we look at other ones, right, we can see that visual indication, right? Here's a test case that we know last time it ran, it failed, and we have a defect that's now associated with it, right? And now we can look into that defect and get that information, right? So from a systems engineer perspective, you can actually track and see where that defect is, knowing that requirement is yet to be, it's got a test case that's supposed to validate it, but it's yet not verified. There is some issue with implementation. We can actually track and see that progress.
Nice.
So
lacking a tool like this, all of this has often been done manually.
Manually, and then so people do this like having some type of Excel spreadsheet. They use naming conventions, things like that. But the thing that they can't do is understand if something does change. How do they know there's going to be impact analysis that's going to be done?
Yeah.
How's somebody going to get notified? Right, that data is not dynamic. It is static, and somebody has to go through and manually update that. And from an assessor's point of view, that is not ensuring consistency.
That makes sense to me.
So,
well, great.
And we can actually now look at, here's some capability that we have that can help drive assessments. We've actually had customers put things together like this. So I'm going to go switch over to a different view here. And let me change the screen size resolution. All right, so what we have here is we have part of our platform, we have a solution called Rational Engineering Lifecycle Manager, and that really does all the indexing of all of the engineering artifacts that we have in our platform and index the relationships that have been established between them, so we can actually create compliance views like this. So here what we're looking at is we've taken our subsystem software requirement specification. We've identified all the requirements inside of it. And now we can look at all the test cases that are associated with those requirements and make sure that every single one of those requirements has a test case associated to it. But we can also look at, but then we're also looking at, well, here's all the test cases now that they've actually been ran. We can see the results of them. And we have the ability to do, things like color code these and make them graphical and visual to help drive an assessment and drive your results. So you can see that some of these have passed, some of these have failed. And from
it looks like you're missing one. There's no link between the second one, so somebody's going to notice that easily. That's a real easy visual aid to let somebody know that there's no test associated with certain requirements.
Yep. We have a gap. right? There's a gap. And that's one of those process areas where you can identify through this type of visualization.
Mm-hmm. Well, that's really cool because we've talked about models for years, helping to visualize things that are hard to identify with text, right? I think it's pretty well known that people are better visualizers of data than readers of data. And so this looks like it could be really helpful.
Yeah, and again, this stuff's all live. So we can look actually into these test cases, right, if we wanted to go into them.
And now this data lives within different tools that are all part of IBM's continuous engineering platform. Is that correct?
That is correct. We talked earlier, Doors Next Generation is where we have our requirements repository. We have our quality manager, which handles all of our test artifacts. So that'd be test cases, the execution records, results.
Okay.
And we have RTC that handles all of our implementation with work items management, change management, defect management, source code management. Yeah.
All linked together. That's cool.
Yeah.
Very good. Well, is that what we have for today?
That is our demo for today, and I'm excited to go to the next podcast. We'll cover, and I forget what is on the next topic, but I think we're going to go dive deeper probably into requirements management.
Yeah, I think that's the key, is to then look at these different areas of which we've just really broad brush stroke the top level, and figure out how to manage our requirements in the context of a SPICE, with which then you'll connect your test cases to, and we'll do test cases on the podcast after that, and then somehow we'll link it all together. So I'm really looking forward to it.
Awesome. Thanks, Brian.
All right, Amit, thanks so much. Amit Talvar from IBM's Continuous Engineering Group, with part of the IBM Watson team. Really appreciate it. Look forward to seeing you next time. Don't forget, we have links down below to other resources, other information. Don't forget to become a follower of our podcast series, and we look forward to seeing you next time. This is Brian Smith with 321 Gang's Technical Podcast. Change the conversation. Take care.